Today we're going to talk about El Nino and the Southern Oscillation. This is an example of how ocean and atmosphere together can make weather patterns around the globe. Maybe you've seen the headlines. The monster El Nino is coming! The Godzilla El Nino is here! The media is all caught up in the 2016 El Nino, which is expected to be larger than average. So what does that mean? Should you be scared? Should you be making preparations? What exactly is El Nino, and what is all this talk about? El Nino is a periodic warning of the eastern equatorial Pacific. Because ocean temperatures are so closely tied to local weather, El Nino affects weather throughout the Pacific and therefore throughout the world, because of course the atmosphere ties everything together. So let's start by looking at a typical ocean sea surface temperature map. Don't worry about the scale, you can't probably read it, but just pay attention to the colors. Warm, of course, is red, and purple is cold. Under normal conditions, the western Pacific, right here, is a pretty warm place. This is the home to tropical islands like Indonesia and Tahiti and to beautiful coral reefs. Meanwhile, the eastern Pacific, off of the coast of South America, is pretty cool. There's a lot of colder water here than you might expect. And to understand this, we really have to look at things in the third dimension. So this is a simplified cross-section of the Pacific Basin at the equator. And remember from our discussion about atmospheric circulation that the trade winds are blowing from east to west at this equatorial position. And as those winds blow, they push the surface water towards the west. So the water crosses the Pacific Ocean and it heats up under the warm equatorial sun. And by the time it gets to the western Pacific, it's pretty warm. So we call that area the Western Pacific Warm Pool. And that's where all those lovely tropical islands are. But if you're pushing water away from South America, then water must be coming in to replace it. And it is. That water comes up from the deep, and we call that process upwelling. The really nice thing about deep upwelling water is that it's full of nutrients for plants and for microorganisms, and therefore bigger critters like fish really like to be in places where there's upwelling. So the west coast of South America is generally a pretty nice place to make a living as a fisherman. Now, under El Nino conditions, what happens is the trade winds decrease. Scientists haven't really figured out why, but the result is that warm water is only pushed partway across the Pacific, and the warm pool moves closer to the center. And therefore, since less water is moved towards the east, less water upwells, there's less nutrients, less food for fish, fewer fish for fishermen. Okay, by now you're probably wondering why all this talk about fish. Well, it was the fishermen who named El Nino. They figured out long before the scientists did that, or they noticed, that there were certain winters right around Christmas where the fishing got really bad, and so they named it for the baby Jesus, El Nino. Now, this is a sea surface temperature anomaly map. An anomaly is a difference from average. So this isn't showing you temperature, it's showing you the difference from an average temperature. If you look here in January of 2015, you can see that across the Pacific, around the equator, things are pretty close to average. It's kind of light yellow, orangish color. That's a year ago. Let's take a look at this year. This is January of 2016, and notice this dark red in the eastern Pacific. This is the hallmark of an El Nino year. The water is much warmer on the eastern part of the Pacific than it normally would be. Just briefly, you may have heard of La Niña. La Niña is, as the name implies, exactly the opposite of El Nino. It is a time when, in the summer, the water in the eastern Pacific is cooler than usual. So you see all the blue off of the coast of South America here. That's the hallmark of a La Niña year. Now, this change between El Nino and La Niña is called the Southern Oscillation. And this is a graph going back to 1950 of the temperature anomalies at a particular point in the Pacific Ocean. And you can see that below the zero line, those are cooler years, and they're marked in blue. Above the zero line are warmer years marked in red. Those are El Niños. The cooler years, of course, are La Niñas. There's a couple things to notice about this. This is a pattern that is certainly regular, certainly predictable or repeatable, and to some extent predictable. It's not perfectly symmetrical. The times between El Nino years are not precisely the same every time. El Nino conditions occur anywhere from every 2 to 9 years, but on average about every 7 years. And La Nina occurs in between, but not always in between. Sometimes you'll get 2 El Ninos in a row without a La Nina in between, or vice versa, 2 La Ninas without an El Nino. We're going to take a closer look at the last 20 years. So this is the ENSO pattern since 1997, and you can see there have been 4 El Ninos in that time. 1998, 2003, 10, and 16. 2 of them have been very, very strong, the other 2 weaker. And there have been 4 mild La Ninas at the same time. Some things to pay attention to or to recognize about this pattern are that this is a little unusual to have 2 very strong El Ninos so close together, but it's not unprecedented in the geologic record. Scientists have been able to go back over 7,000 years looking at annual temperature records in the Pacific, and those records are based on fossil corals. And this kind of variance is seen in the past as well. So it's not high, we don't have a higher than average or more strong El Nino than we have seen in the past, but it certainly seems strong in our lifetimes. So how does El Nino affect the weather patterns around the world? You can see that it's a worldwide phenomenon, not just a Pacific phenomenon. In the Western Pacific, where it's normally quite tropical, it will be warmer. It'll be warm in some places and drier than usual in much of that area. It will be warm and dry in South Africa, warmer in Australia. You can see even in the eastern part of South America that there are changes in the weather patterns. If we look a little bit more closely at North America, what we expect to see is warmer from Alaska through northern Canada, and the northern U.S. states. Dry out in the Ohio Valley, Mississippi Valley states in the mid-continent, and wet across the southern states. So be prepared. We should be looking at a wet winter here in Texas.